So good morning, everyone. Welcome to the lightning presentations focused on current interdisciplinary team research projects at UNM. This morning, we're going to hear from 4 presenters, each of whom will present for 5 minutes or 7 minutes and then answer questions for 5. To help us keep on schedule, I will cut off questioning at the end of the 12 minutes total. So Dr. Crossie, why don't you take it away?
Well, thank you, Tim, and thanks everyone for organizing this meeting and this concept. I think that this team research and finding new ways to reach out and collaborate is just a fantastic idea. My talk is on chasing helium, continental smokers and extremophiles. And this sort of angle of research, which is part of what I've been doing here at UNM over 36 or 7 years, comes from a kind of a love that Professor Cliff Daum, who's now emeritus from biology, and I sort of shared, and we met at a function at UNM in the early years when I came in 1985. He'd been here for about a year or two before me, and he worked on some systems that were really exciting new finds at the time in an overlapping disciplinary study between geoscientists and microbiologists and chemical oceanographers. I'm just going to show quickly a video of a system. This happens to be in Tibet that I just took in 2017 on a kind of extension of this work. But this is a spring on land, not deep in the ocean, that reflects some really extreme and unusual organisms that are living in this very strongly carbonated terrestrial spring, forming beautiful deposits, mineral deposits, which we have many representatives of these environments here in New Mexico. But here we are on land, adjacent to a river, in an incredible tectonically active landscape. So this is the kind of system that I'm very interested in. My other collaborators on this rather long journey, which started with informal conversations, other types of collaborations, eventually an NSF grant, multiple students working on different aspects of this sort of linkage, includes my husband and colleague, Carl Karlstrom, who studies neotectonics, among other aspects of geology, and Tina Vesbach, who is a microbial ecologist who brought to this collaboration many of the amazing techniques that we use to identify microbial communities. Students that were engaged at various points in time include Brandy Kemmermans, who was a biology undergrad, then got a master's in earth and planetary science, eventually went on to a PhD, Dan Coleman, and Dennis Newell, all of whom are still active in this sort of angle of research in their careers today. So the mid-ocean ridges were the site of this incredible discovery of black smokers in the world ocean system, originally discovered by geologists, but very quickly they grabbed their biology colleagues, dragged them down, including people like Cliff Daum, shown in the upper right, who went down in the Alvin as a young chemical oceanographer during his own training. So these communities are what we call chemolithotrophic, unlike organisms and ecosystems that depend on sunlight for the primary photosynthesis, and the energy kind of flows from the base of that pyramid. These systems are built up on chemical exchanges. As a low temperature geochemist, this was a really exciting idea for me. So when I came to UNM, these had been discovered in the late 70s, and it was sort of the early 80s. And so I was still really excited about this new adventure. My field areas for looking at these systems on land, which is carbonic springs, includes the Colorado Plateau, shown here on a digital elevation model of the Western United States, the Rocky Mountains, the Rio Grande Rift, where we live today, and in particular along the Grand Canyon. And I'm showing some pictures on the right of some amazing springs erupting into Grand Canyon because of the deep incision of the Colorado River that produce these incredible travertine mineral deposits. They also have these bubbling characteristics. And the question is, what is the root of these systems? I wasn't so much interested in the beautiful part that we see here, but rather getting into that hole, which is shown here, where the spring is emerging from the rock. What is going on in these systems that leads to these incredible characteristics? And is the ocean overrated? Would we find things like black smokers on land? Does the ocean part really matter? So here's a diagram on the left of a schematic of the sort of scientific interpretation of the deep circulation and geothermal systems that give rise to the black smoker chemistry, which includes reduced gases and allows the flourishing of these systems. Now, people very quickly also mapped out extremophiles associated with places like Yellowstone, very young steaming volcanic system with these incredible biological communities. So these are called proximal magmatic settings, really active systems. And there we found thermophiles, hypothermophiles. The life zone is very compressed for the thermophilic parts of the organism because the environment quickly equilibrates to the surroundings. And forward. They had the presence of high CO2 and these reduced gases that can serve as a metabolic substrate for these unusual organisms, which are shown here in this kind of cartoony version of the tree of life, are all what we call very deeply branching, very primitive types of microorganisms. So the idea was, what about extensional tectonic settings like the Rio Grande Rift? Don't we really have the same assemblage of things that we need? This is where I come to the idea of is the ocean highly overrated? How does the organism know if it's in a mid-ocean ridge or in the Rio Grande Rift? So we have many of the same assemblage of features. Shown here's a cross-section of our own Rio Grande Rift. When we zoom up close, we see these incredible CO2 vents building mounds like this one here pictured right near San Ysidro off of Highway 550. In fact, these are not as hot. And so they might have a more expanded life zone. They may have properties that are not displayed by these organisms that are also thermophiles, and yet they still have the same metabolically reduced pathways. So we went on a journey to do the microbial culturing, to understand the chemistry of these systems. And part of it was to demonstrate that we actually have these kind of deep tectonic connections. And we did that by using a silver bullet. The CO2 is processed so heavily that we can't uniquely demonstrate that the CO2 is coming from those sources. But helium, the trace helium amounts in that CO2 gas provides a silver bullet for establishing a tectonic connection. So this is how we capture the bubbles. We bring them back in the vacuum bottles. We have so many fabulous facilities and research technicians that help us and our students here at UNM that we were able to ascertain that we have the trace amounts of helium gas in the CO2 of these bubbling springs, including in New Mexico, that show that they have this deep tectonic connections. The nitrogen to helium ratios are very, very low. These gases that are bubbling out are not derived from Earth's atmosphere. The helium to neon ratio is much, much greater than air. It would be less than 1 as compared to 500. And the helium 3,4 isotopic ratios are the silver bullet that demonstrated to the geoscience community that we had this tectonic connection. Is that surprising? Not really. We do have young volcanism. We have basaltic magma, which is another extract of Earth's mantle. And with the advent of EarthScope, which is the geoscientist version of the Hubble that looks deep into the Earth, we were able to make an image like this one, this colorful image here, which maps out areas of mobile mantle material where we have potentially partial melts and higher concentrations of CO2 that are coming out of the mantle. This is a slice of the Western US taken at much greater depth, like 60 kilometers. And the bubbles, the big bubbles, represent high helium 3,4 ratios, which we were able to demonstrate had a very good correlation with this tectonic setting of the Western US. So I mentioned the connections to extremophiles. We went in and used with Tina Vesbach's lab and her techniques. We went and did microbial, both archaeal and bacterial sequences. And I just want to kind of come to the bottom line that we found springs with high CO2 right here in New Mexico that contained organisms that were part of the Zeta proteobacteria, which previously had only been detected in marine environments and were thought to be obligate marine organisms. We also found Meroprofundus ferroxidans, which had only been characterized at mid-ocean vents right here in the Rio Grande Rift. So that was just a really exciting story that never would have happened without linking arms across the communities of biology and using the facilities that we have here at UNM. Just to bring it home, I mentioned the water group that's here in Great Forest today. Who cares about this? Well, when we think about the Albuquerque Basin and the reliance and increasing dependence in the Western US on groundwater supplies, heading into a changing future with diminished surface water flows, understanding the mixing of these fluids has a big impact on our understanding of water quality. So there are practical reasons for this, but of course, the main reason that we all got on board with this was because it was just darn fun. So I have some other materials, but I'm probably pretty close to my time limit. Tim, do you want to let me know?
About 10 minutes, so you have 2 minutes for questions.
Great. Maybe I should stop sharing and so we can be more, whatever you say the word.
Yeah, that sounds good.
It's kind of hard to ask questions when something goes so fast. Does the ocean matter?
Lori, this is Chris Lippitt here. I wonder if you might elaborate a little on what the implications for the groundwater might be.
Sure. Sure, those flow paths were shown that, very schematically going deep into the earth. When water goes deep into the earth, it's warmer, it interacts more with the earth materials, and it extracts things from that deep circulation process, including metals. Arsenic is commonly associated with these kinds of systems with magmatism, and so we know that we have circulation like that. In northern New Mexico, we see the geothermal fluids that are still distal to the Valles Caldera, a very young volcano, and that fluid is circulating out and impinging on the groundwater systems in the northwestern part of the Albuquerque Basin, which is one of the places where we have the highest difficulty in dealing with arsenic in the groundwaters. So that's just one example. Uranium is another element that can be a little bit more abundant in systems like that because of the high CO2. Uranium loves to combine with CO2 in its various forms in water.
And we are out of time. Thank you so much, Laura. That was great.
Yeah, thanks, everybody.
I always love.
I do see a chat question from Mary Jo. Maybe I can just kind of answer this. Yes, they do. They are in other land areas, not just in the US, but in Egypt, Tibet, the outback of Australia. The search for these systems has taken me kind of all around the world. Always these springs are very important to indigenous cultures. Very rarely are they good drinking water, but they are treated with great respect because they're obviously unusual and coming from the deep earth.
Okay, Dr. Pearson, you're up. Can you share screen? Perfect.
I'm gonna go. Everyone can hear me? Can you hear me?
Yes, and
Okay.
your screen is great. Thank you.
Great. All right, so I'm Mateo, and I'm a researcher at the Center on Alcohol, Substance Use, and Addictions. And it really is my great pleasure to be talking with you all today about a project we put together for a center grant application recently. So to give a really oversimplified, quick review of the problem, chronic pain is a really debilitating condition. And unfortunately, most trials testing pain management techniques exclude individuals who have an opioid use disorder. Opioid use disorder by itself is another very debilitating condition, and most of the treatment studies of opioid use disorder exclude individuals who have chronic pain. So what we're left with is individuals with co-occurring chronic pain and opioid use disorder, among other common co-occurring conditions, where they're not really getting the attention deserved in terms of developing and testing effective treatments. So this is kind of the problem we're trying to address with this center application. So it's called the UNM IMPOWR Center. So IMPOWR, that's NIH's acronym for Improving Management of Pain and Opioid Use Disorder for Whole Recovery. And that whole recovery point's pretty important to us. So we take an integrated and holistic approach, and practically what that means is rather than looking at, say, a single reduction in symptoms of pain or increases in abstinence from opioids. We're really looking at quality of life and overall functioning outcomes at the level of our clients or patients. And I'd like to think of like integrated treatment of getting past this or that treatment and doing this and that treatment, integrating behavioral treatments and pharmacological treatments and any kind of treatments together to more comprehensively address these issues. I'll mention that one of our trials is more focused at the patient level intervention, and one's more focused at the provider level. But regardless, we're trying to get these effective interventions implemented as quickly as we can. To do so, we're embracing principles from community-based participatory research, which we'll talk a little bit more about in a moment. We're all here at a team science symposium, so integrating the effective techniques gleaned from the science of team science is really important. And then we kind of recognize this this urgency to get things into practice. So we use hybrid effectiveness implementation designs that can kind of speed the gap between kind of initial efficacy effectiveness research to getting things implemented in the real world. So this is my kind of it takes a village slide reviewing the team. So alongside Katie Witkowitz, I'm one of the principal investigators for the application, and we really are leading alongside a scientific advisory board that has pain, opioid, and implementation science experts, and very importantly, along with a stakeholder consultation board or a community advisory board. And the members of this board, they include individuals who have lived experience of chronic pain, opioid use disorder, and these other co-occurring conditions. They've all had very unique pathways to recovery or management of their conditions. And as well as we have frontline treatment providers, and we'll be adding to this team with individuals who are advocating for these patient populations. So in addition to the two trials I'll talk about, so we have the HOPE trial and the OPTIC trial. In addition to that, we have kind of a mechanism for pilot funding. It's really important to provide early stage investigators opportunities, kind of get a footing in the field. We have an economic evaluation team. It's really important for, to communicate this to policymakers, to show dollar for dollar that these interventions are worth their while. And of course, we have a great admin group to help with facilitating actually getting all of this done, and folks with a lot of experience collecting the clinical trial data that we need. So this would be one way that we look at our team. This is the way that NIH forces us to look at the team. Here's another way to look at our team. I can't embarrass everyone all at once because a few people were missing, but there's a bunch of serious scientists being kind of silly. I mentioned the community-based participatory research. In terms of embracing those principles, these are the principles that we went out when we were recruiting our board members and saying, briefly, the idea is here is that we're not interested in helicoptering into a community, getting some data and leaving. We really are trying to develop long-term sustainable relationships that are going to last beyond the period of this specific study. So briefly, the HOPE trial stands for Healing Opioid and Pain with Engagement. This is a hybrid effectiveness implementation trial testing the efficacy of among individuals who are getting buprenorphine for opioid use disorder, adding mindfulness-based relapse prevention and acceptance and commitment therapy. Mindfulness-based relapse prevention has been known to be efficacious for substance use disorders, and acceptance and commitment therapy shown to be effective for chronic pain, and their combination based on pilot data seem to be very promising for those who have co-occurring chronic pain and opioid use disorder. The OPTIC trial, which, oh man, I think I blanked on what the acronym means, and I created it. Opioid and pain treatment in indigenous communities. So this trial is focused on American Indian Alaska Natives. And this one's more of a provider level intervention targeting with I think the backbone being Native American motivational interviewing, which is kind of been shown to have efficacy in this community. But really there's a hefty component of working with the community to develop the best implementation strategies for the communities that we serve, to get them to find the best ways to increase the screening for opioid misuse and opioid use disorder, as well as screening for pain and brief interventions for those and potential referral to treatment for those. And I know I'm going very fast. I was trying to get to the questions as soon as possible. So thank you all for your attention, and I'm prepared for questions.
So Mateo, we have a question in the chat. Do you view the participants from communities as part of your team? If so, how do you engage them in the design and carrying out of the studies?
That's a great question. Kind of depends, but yes, briefly. So for each of the trials we're developing these community advisory boards of people who really are equal partners on the team. And some of our participants are the providers. And we have kind of qualitative pieces of these studies to get get feedback from the boots on the ground. Let's see. And yeah, I think it was important in the call, and I'll tell you, as a person who went 180, I have not touched anything related to community-based participatory research in my career, and frankly let's say I didn't see the value perhaps, and this has really turned me around. And I feel like, yeah, I said this to all the people involved with the trial, that I'm never going back. That this is, again, if you're really interested in implementing long-term sustainable change in the communities you're working with, like, this is the way to go. So any chance that we have to elevate participants to be partners, we'll take. And especially for the optic trial, where there's a good, like, a year plus time period where we're going through this iterative process to figure out what would be best to implement in the specific communities. Oh, sorry, I can't. I'm going to stop sharing.
That's another great question. Were incarcerated individuals included in any of the studies? So no, not at this stage, although two of the collaborators on the project are working with incarcerated populations, and that's one thing we might pursue in one of the pilot projects. So we have a pilot core, and our colleagues have been working with buprenorphine engagement in NBC and other facilities, and so I think that could potentially be a pilot project that we would fund. We're very interested in that. Thank you. Any other questions?
I guess I have one. I'll do it verbally, though.
Great.
Break the norm.
So when you have these large team projects, how does that affect the graduate students and their career trajectories to get them engaged in these big projects?
Katie, you want to take that one?
Sure, I'm happy to take that one. Yeah, I think it's a great question, and a lot of the center is focused around postdoctoral training, and we have postdocs in every project and every piece of it. We do envision graduate student involvement in each of the trials as well, just as you would have a graduate student involved in another kind of R01 or R21 project where graduate students would have the opportunities to use the data that are collected, also get training from, in working with community-based participatory research, training and working in team science, and also would be, encouraged to publish findings from the trials, or potentially add measures to have their project, kind of thesis and dissertation projects be part of the data collection that's ongoing for the trials. So that's a great question. And we've always kind of integrated across the hierarchy of senior scientists to early career to postdoc to grad students.
Excellent. Okay, so we are out of time. So Heather, if you would like to share your screen and go ahead and get started.
Okay, I will do that. Let's see here, share. Okay, is it, now I gotta move this. Okay, is it sharing my screen now?
It is, thank you.
Okay, great. All right, so we're gonna switch gears a little bit and talk about a subject that I have titled Water is Not Just for Engineers and Scientists. So just real quickly, I'm the director of a center called the Southwest Environmental Finance Center, and we're located within the School of Engineering and the Center for Water and the Environment. And we have our mission statement as promoting self-reliance through innovative training and assistance focused on actionable results. And I'm actually an engineer by training, so I have a BS and MS in environmental engineering, but I say that I do operations management and finance by choice. So I spend most of my time out in what we in universities often call the real world, working with water utilities all over the place, so all over the country. So yesterday we were doing a broader impacts presentation, and I talked about how our reach is about as far in the US as you can be. I've been to all 50 states multiple times each, worked with water and wastewater in just about every one of those places. I also go to all the territories, and there's a picture in the upper right. That's when I was in the Northern Mariana Islands. And then in the middle, you see me on a oil rig in the Gulf of Mexico. And then we had a thing at the White House. So we end up all over the place doing all kinds of stuff. And I love being out and about with water and wastewater utilities. So what I would say is that we've learned recently with our project is we need to really blend arts and sciences to communicate outside our bubble. We spend a lot of time kind of talking to each other and people who are in the same type of fields and understand the same lingo. And we can spout our acronyms and all of that stuff really well, but does anybody else have a clue what the heck we're talking about? So we really need to get outside of our comfort zone, maybe to talk to people who can help us share the message beyond, our water professionals and reach the broader audience. So we really kind of need to think about how to move beyond our inner worlds and engage other professionals who have different viewpoints and who think about things differently. So I will share our little story with the grand challenges, and UNM had these grand challenge opportunities, one of which was water. And we went in very skeptical. So we started out as the picture on the left as, what is this all about? Why would this really involve us? And it ended up like the picture on the right. Extraordinary glad that we did this. It was only just a tiny bit of funding, just for very specific purposes, but it really had an impact so far beyond what we were doing. So it was kind of a chance to reach across campus and work with people that we knew either a tiny little bit or we didn't even know existed. So we literally were making calls like, I know you don't know who we are, but we have this proposal due in a couple days, and how about working with us? And lo and behold, folks were willing to do that. So first part about what I'm going to talk about is our grand challenge team. And we had a team of film and digital arts, geography and environmental studies, community and regional planning, and ourselves at the Southwest Environmental Finance Center. And there's some folks in the middle there, James Stone, Joni Palmer, Dan Galasini, and then students in all of those departments who worked with us on this project. So it was a interesting collaboration because it's one that we never did before. And honestly, before the Grand Challenge, I didn't even know UNM had a film and digital arts program. So it really got us outside of our comfort zone big time and introduced us to other people. So one of my goals for a really long time has been to create this Khan Academy type program for water. So the Khan Academy is where you can go to learn about math and science and all kinds of things. And they have areas for students, teachers, and parents. We wanted to have areas for the general public, elected leaders, and water professionals. So it's really a chance to stretch that atrophied side of our brains, that creative side. So we spend so much time in the math and science area and not that much time in the creative side. So it's really a chance to kind of open up our brains to a new way of thinking. And we have created through our Grand Challenge funding, the Environment Focused Learning Academy. So on the right, you see our landing page. We created a little logo, and we created our mission statement to expanding knowledge about value and stewardship of water within our communities. We do eventually hope that this grows beyond water, but it for now is very much focused on water. And it includes podcast resources, science, video. So we have a series of podcasts that we created. We didn't actually intend to do podcasts when we started out, but COVID kind of changed our plans tremendously. We had all kinds of plans on doing man on the street interviews, all sorts of stuff, and we had to greatly change because I think our project kicked off in January and COVID started in March. So that greatly upended what we were going to do. But we created a bunch of podcasts that talk about water professionals as frontline workers, and they're often forgotten about as being frontline workers and how important they were. We also created some videos. We have some of ABCWA, the Albuquerque Bernalillo County Water Utility Authority, and then City of Santa Fe. We also worked with a woman from the College of Pharmacy who is both a scientist and an artist, and she created this graphic for us that's Native American symbols to communicate water disinfection. So we have one of those. We had actually put in a proposal to try to do some more, and unfortunately that wasn't funded, but we're still trying to get some more of these created. We created some resources. On the left is a poster. The Grand Challenge had a poster initiative, and one of our students created the poster on the left. And that poster won the Grand Challenge prize for a student poster. And on the right, she created another student, a couple of students actually created a tap water, bottled water sort of white paper that people can go on and read fact-based information about the difference between tap and bottled water. And our latest thing, which I'm going to put something in the chat, because we're going to introduce our animation to everybody tomorrow at the sub. So we're going to show it at the sub and have an event. And I have a link to our social media accounts where you can find out more information. But we've created a whole animation about bottled water and tap water that will be again added to our site. And what we're trying to do is show all different ways that we can communicate. And when you have this sort of blended environment, we can communicate in different ways because people who are in film see things very, very differently than engineers in water. And that has really helped us tell stories and provide information in a better way. So we do have other collaborations. And one I want to mention now is with the Department of Economics. So a big idea in water is that we have this need for economy of scales, that bigger is better. So we wanted to kind of explore this idea, is bigger always better? Or is there any limit to how big you ought to be? So myself and Jingjing Wang from the Department of Economics had lunch one day, and it was just a welcome back to campus kind of lunch because Jingjing had been gone and came back to UNM. And we were just getting together and just kind of saying hello again, and we got into a discussion about water. And Jingjing was saying she'd like to get some data on marginal cost of water. And I was telling her, hey, I know where you can get that. There's a bunch of data out there for water audits that will get you exactly what you want. So we birthed a partnership on regionalization. So for a water person, economy of scale is the answer. Bigger is always better. And for an economist, there's a bathtub curve with an optimal size utility where if you're smaller than that size, it's more expensive. If you're larger than that size, it can actually be more expensive. So we're actually working on a joint article. It'll go into a water journal and an economics journal. And Mandy Liu is also working with us on this, a PhD student in economics. And we got some data from Georgia and Tennessee to kind of test out the bathtub curve. And Georgia had a better range of sizes, so we could actually test out the bathtub curve and really saw it. Tennessee was a little bit too small. Their biggest systems are actually not very big, so we didn't see quite as much, but brings up some interesting conversations to be had about how big is an optimal size utility, and should we be focused on trying to create certain size utilities, and that sort of thing. So what's next is we're looking to apply for additional funding. We've built this work into approximately 7 different proposals thus far. We're waiting to hear back from, I think 3 of them that are still out there. And we still want to keep going with these types of collaboration. We really want to expand our environment focused learning academy. We want to keep that content coming in. We want to work with others to try to add content. So over time, we hope that it's not just us putting content up there, but we have collaborators who want to put stuff on the site so that people can go there and find neutral fact-based information. And we're always looking for opportunities for more collaboration. We want to reach other parts of campus and really work together. And right now we also have an additional collaboration with geography, where we're doing a survey of water utilities throughout the state of New Mexico. And we're working with utilities, or working with folks from geography to make that happen. So I think our message is that once you get out of your bubble, you can find a whole world out there. And, you know, we've been at UNM, or we've been in existence since '92. And we had one brief period where we were at New Mexico Tech, but other than that, we've been in existence this whole time. And I think we've been so inwardly focused that maybe a lot of UNM didn't know we existed, and we were missing out on some of these collaborations. So we really want to look for, you know, additional opportunities to collaborate around campus and find out who else is out there who can help us get our message across. And with that, I don't know where we stand on time, but
You have
I
time
can
for
open
one question.
Oh, okay. And I will send this announcement out as well. Somebody said, do the studies include both rural water co-ops and metropolitan? Yes, absolutely. We work with everybody, from the smallest of the small to the biggest. In fact, recently we've had several big cities work with us. So we're going to be working with Seattle, or we are working with Seattle, and Minneapolis is getting ready to kick off. We've worked with one of the islands in Hawaii, and we're starting a project in the Northern Mariana Islands that kicked off last week. So we have projects near and far with all different size water utilities.
Okay, and that's pretty much time. So Alex, you're next.
Great. Let me go ahead and share my screen. Okay. So hi, my name is Alex Webster. I'm a research professor working on the Sustainable Water Resources Grand Challenge. So I'm going to round us out today with another project from the Sustainable Water Resources Grand Challenge. And I'm here today representing our much larger leadership team, who I'll introduce momentarily. So I'm going to jump right in so that we can get to them. So preliminaries, New Mexico is, by some estimates, the most water-stressed state in the nation. We face decreasing usable water supply alongside increasing water demand. While marginalized New Mexicans bear disproportionate hardships stemming from this scarcity, as demonstrated here by the hotspots of plumbing poverty found in our state. Climate change is, of course, predicted to worsen this situation by stressing our ecological and hydrological systems in a lot of unprecedented and potentially multiplicative ways. And all of that is going to have cascading effects on our infrastructure, our governance systems, our economy, and our well-being as a society. So the Sustainable Water Resources Grand Challenge team is addressing those looming challenges through an interdisciplinary sustainability analysis of New Mexico's water resource systems. So I want to talk today about what I mean by an interdisciplinary sustainability analysis. So first, we're a truly interdisciplinary team of researchers from all across campus. So our leadership team alone pulls from 9 different departments, including Carrie Howe and Mark Stone from the Department of Civil Construction and Environmental Engineering, Marcy Litvak and myself from the Department of Biology, Benjamin Warner and Melinda Morgan from the Department of Geography and Environmental Studies, Sang Han from the Department of Chemical and Biological Engineering, Kathleen Cambick from Architecture and Planning, Adrian Oglesby from the Utton Center in the School of Law, Jingjing Wang from the Economics Department, and finally Laura Crossie, our first speaker today, from Earth and Planetary Sciences. So together, our team expertise ranges across infrastructure and water treatment, ecology, hydrology, geochemistry, urban and environmental design, governance, and political ecology. So I was brought on into this amazing group specifically to try and quantify and monitor sustainability. So my first question was, how does this team, a team like this, think about sustainability? And so to get at that, I interviewed each member of the team when I first arrived at UNM about this question. And we were all able to more or less agree on this basic definition that sustainability means meeting the needs of the present without compromising the ability of future generations to meet their own needs. But when I dug in further, some more nuanced perspectives on the components of sustainability started to emerge. We all agreed that balancing supply and demand is one important component, but we also agreed that this is not enough. Given the uncertainties surrounding our state's demographics, our economics, and vulnerability to drought and natural disasters, our water resource systems must also be able to withstand and bounce back from unexpected changes in order to be sustainable. And so this is the concept of resilience, which has various roots in physics, engineering, and ecology, but has really spread to many other disciplines as a uniting concept. Finally, we could all agree that parts of our water resource systems are imperfect or inevitably will change in the future, and being able to guide that change on intentional trajectories was another essential component of sustainability. So this is the concept of transformative capacity, which has emerged from resilience theory, but it's mainly been studied in more governance-related fields. I want to note, though, that engineering and economics are also really closely linked to this concept because innovations, which are really central to those fields, are often drivers of trends in transformative capacity. So together, these concepts have really been able to unite our team. So each of these concepts has really different both quantitative and qualitative methodologies associated with them. So the next challenge was to find a common framework that could organize and unite these disparate methodologies into a single sustainability assessment. For this, we're harnessing the social ecological systems framework. This is an analytical framework that highlights interactions through which social and ecological systems are linked and tend to feed back on each other. And it provides a tool to really identify variables and interactions that might not otherwise be considered in a lot of analyses. So we're using this framework to identify the key ecosystems, infrastructure networks, governance systems, users, managers, and communities that make up New Mexico's water resource systems and assessing how they interact to impact water sustainability. Each subsystem and each system of interactions represents a system whose resilience and transformative capacity can impact the overall outcome of water sustainability. So in the process of identifying these subsystems, we're identifying quantitative indicators of their dynamics from available data streams, such as, say, satellite imagery and remote sensing products, river flow and water quality monitoring, land ownership and use data, and demographic trends. So this kind of indicator data is then used to quantify resilience of different system components using quantitative resilience theory and statistical modeling. So I want to give you a taste of a couple of the collaborations within our team that's emerging within this framework. So and then how those collaborations fit into the larger team goals. I've been working with Marcy Livek to understand the resilience of our subalpine headwater forests, for example, which are really critical regulators of our snowpack resource systems. And we are comparing them to the resilience of some of our other biomes in the state, like juniper woodlands and grasslands. We're using net ecosystem exchange data from her eddy flux towers around the state, which provide a really excellent indicator of the ecosystem state and its stability. So here I'm showing 3 of her 7 sites and the flux data sets of net ecosystem exchange. I've calculated temporal autocorrelation and kurtosis across these flux data sets, which are statistical metrics of system stability. And these kinds of metrics have been used successfully to forecast regime shifts in other systems, both in ecology, but also in economics and climate systems. So preliminarily, we found that the juniper woodlands and the grasslands are really remarkably resilient to fire, bark beetle-induced mortality, and extended drought, as demonstrated by the lack of change in the stability metrics that I'm showing plotted here. The coniferous forest, however, demonstrated a period of really high instability following the 2013 Thompson Ridge fire that occurred in the region, and was accompanied as well by a shift to a lower productivity regime. And so together, these results suggest that the forest may have crossed a tipping point into a new state, and that according to resilience theory, that state is now less likely to be able to be easily brought back to its previous state. Okay, another collaboration is to examine the transformative capacity of collaborative governance systems for water management in agricultural communities. This is something that I'm working on with Caroline Scruggs, Mindy Morgan, and Jingjing Wang, and we are pursuing this through a proposal to document emerging innovations in water management in agricultural communities by using in-depth interviews and stakeholder workshops. So these interviews will be used to identify characteristics known to support high transformative capacity, including the existence of diverse community-based experimentation, leadership that effectively translates information across governance scales, the emergence or arrival of new technologies, and many other characteristics that have been associated with high transformative capacity. So finally, I want to end with how this will all come together. So we're looking at all these different systems and simultaneously characterizing the larger system within this framework. In the short term, what I hope to do with this is to develop qualitative mathematical models, also called sign diagraph models, which represent complex interconnected systems like this as a web of positive, negative, and neutral interactions and their relative strength of interactions. So the social ecological systems framework can be directly translated into this qualitative mathematical model. And the power of this kind of model is that it incorporates variables and processes that are difficult to measure by relying on the general shape of functions and their relationships between variables. So it's a really good way to capture the complexity of a system like this without having to have a perfect simulated representation of some of the more nuanced characteristics like that transformative capacity. So once the structure is defined in a model like this, one can test how changing conditions and disturbances reverberate through the system to affect other subsystems. As we improve our ability to simulate those dynamics, these semi-quantitative models can be adapted into fully quantitative models, such as system dynamic models, which are then you can use to predict and play around with different scenarios and their sustainability outcomes. So some concluding thoughts about the direction and hope of this project. So to characterize each subsystem and to assess its resilience and transformative capacity, and then to incorporate this information along with our current understandings and forecasts of supply and demand is obviously a really large ongoing project, as is appropriate for a grand challenge. But as we work towards that goal, we think that identifying and filling gaps in the conceptual and mathematical models that I've given a taste of today provides a common goal for water resource researchers across a lot of disciplines and a home for many otherwise disparate studies and findings. So we think that every stage of this work will inform the water resource research conversation throughout New Mexico by promoting the use of resilience concepts and sustainability efforts, and by identifying more leverage points for managing towards sustainability, and finally, for identifying those key gaps in our understanding of the system. And with that, I will stop sharing, so maybe we have time for questions.
So we're just at 12 minutes. So I think at this point, we've still got 10 minutes. So I'd say open it up for questions for any of the presenters and let's use the last 10 minutes, however it shakes out.
I wanted to mention quickly, if any of the presenters want to download their slides into a PDF, I can attach them to the session in Attendify so that attendees can get copies of those slides if you want them.
So I have just a comment more for Alex. It's like, how does your head not explode? This is so complex. I guess
I have a great team that I'm working with, and I like to remind myself that, you know, that it is a grand challenge and that I, by myself, would never be expected to fix it.
I'm really impressed though with the, you know, having a model or structure around to try to organize all of these changing parameters. And I look forward to you having the solution here before the end of the century. I don't know, what's the timeline? When do you have it figured out?
May.
Oh, May, okay.
Yeah, I think the qualitative mathematical model I presented is certainly within reach, you know, especially for some of the more simpler subsystems. And so, you know, it's all about balancing trying to build to the eventual big grand model, but also learn as much as we can along the way and provide, you know, really identify the gaps where we should be focusing our research efforts.
Well, it's great work.
Thanks.
I have one question, comment, and this is for Alex and Heather. So Alex, you're developing, as Mary Jo mentioned, a lot of, you know, complex issues here, and it seems like this is there should be a great connection between the communication that Heather has been developing and the, you know, science and sustainability that you've been developing. So how do we get the two of you to connect and move both those things forward?
Yeah, I was thinking the same thing during Heather's talk. I think we should definitely chat about ways to communicate this.
Definitely.
I will buy you coffee.
Yeah, exactly. So we just, you know, Jingjing and I went to the university, what's that called? University club or something that's on the north side of campus. And whenever they open that back up post-pandemic. But yeah, I think there's lots of opportunities for different kinds of communication. And that's kind of why our site has so many different styles of communication, is we were hoping to just, you know, demo lots of different ways to share information so that hopefully some way hits with a particular person. They can pick and choose the types of things they want. So we would love to talk more about how can we help, you know, bring pieces together, because a lot of our work has been for years and years just more in the water professional side, and it's super, super important that we get out of that bubble and, you know, get out into the rest of the communication, especially elected leaders too. I mean, they're the ones making decisions, and trying to reach them is super important.
Absolutely. And one of our team's goals is to really engage intensively in stakeholder outreach this next academic year. So it would be fantastic to collaborate on how to do that really effectively.
Alex, do you want to mention the class you have going this semester, which, you know, is a way to solicit at least some of the stakeholders and engage them with the UNM students?
Yeah, I'm teaching what I'm calling a stakeholder-driven data analysis class this semester as well, which I didn't have time to include in here, but has a lot of kind of synergistic interactions with this project of mobilizing data streams with the help and hard work of a bunch of grad students learning data analysis for the first time, and also, you know, returning directly a product to stakeholders in various agencies that provided that data. So it's a kind of a stakeholder engagement and teaching and working and preparing some of this data for this modeling assessment all at once. So it's been a really fantastic way to bring some of this together and extend it into the grad student community.
And I will mention too, we've been trying to move into social media, and I am a person who just loathes social media. So this is a new thing for us too, of trying to start Twitter and Instagram and all these different things. And one of our students researched all the different platforms for social media, at least the ones that are not in the dark side of the web, but just the regular web, and really has helped us figure out like which ones of those social media would work best for, you know, communicating water issues to that crowd. And so we've definitely been expanding that. And we had a little event on April Fool's Day where we told water jokes, and we reached out and we went from like 2 followers to like 60 in a day. So we felt like that was pretty successful, and we got some interesting water jokes too. So we're trying to move into that social media world, which again is a new thing for us. And we're expanding more into that world of how can we communicate through social media, because it is not the world that I like to inhabit. It's not my happy place, but we're moving into it and we're finding ways to communicate that way as well.
And if, I don't know if Katie's still on Witkowitz, but you know, something to think about in terms of looking at what the Waters Group doing is using these multi-modes of communication for the substance use too, and particularly with policymakers and providers and communities.
Yeah, no, it's I'm still here, and yeah, I was listening with great interest, and definitely, you know, one thing, it's definitely what we're moving towards as well. So thank you to the water group, and maybe we could meet to talk about what's worked and what hasn't worked. We're also, our new assistant professor who's going to be joining us in the summer is really into science communication and social media. So, and has had a lot of success with that early in her career. So I'm excited to bring her into the fold, and maybe we could share our path on social media and how we were integrating with that with the water team and have some synergy.
Yeah, and I would love to learn more of what you all have discovered from your participatory research framework and how that's gone.
Yeah, wonderful.
Well, thank you, everybody. I think our time is up. So a big thank you to the presenters, and enjoy the rest of the symposium.